All right, let's get right into it. What if I told you that the global chip war, the massive battle for the future of all technology, is actually already over? Not that it's winding down, no. I mean, as of 2026, the winner has already been declared.
And look, this isn't some wild prediction. This is a conclusion, and it's based on official production data that has sent absolute shockwaves through the industry. One source even called it a death sentence for the competition.
And the result? It is brutally clear. TSMC is the undisputed winner, and Samsung and Intel? They're not just trailing behind. They have been completely lapped in a race they were supposed to be co-leading. It's not just a technical lead anymore. Honestly, it feels like they're operating in a totally different dimension.
So that brings us to the real question here, right? How on earth did this happen? How did a single company build a technological fortress so high that nobody else can even peek over the walls? Well, the answer is in the details, the kind of details the competition just can't seem to copy.
First things first, we've got to bust the biggest myth in the entire chip industry. A lot of people think that success just comes down to owning the most advanced, most expensive lithography machines from ASML. But that's just not how it works.
You see, having one of those incredible EUV machines, that's just the price of admission. It gets you a ticket to the game, but it doesn't teach you how to play at a championship level. And TSMC has proven that the real victory, the real advantage, is won in the microscopic details. In technologies the rivals can't even get to work in a lab, let alone mass produce.
So, let's see exactly how this happened. We're going to go deep inside the 2nm chip itself, because the first major clue to TSMC's total dominance is found at the atomic level, in the very heart of the transistor. At this tiny scale, the entire game is about a new architecture called nanosheet transistors. Think of it like a tiny, multi-lane superhighway for electrons, built from these impossibly thin, stacked sheets. But here's the catch. To make it work, every single one of those sheets has to be perfectly atomically flat. Any bumps, and the whole thing fails.
And this is where you see the night and day difference. Samsung's process, it creates these uneven, bumpy layers that causes electrons to leak out, which generates a ton of heat and just terrible performance. Their yields, they're stuck below 60%. Meanwhile, TSMC has achieved this atomic-level flatness, creating that perfect superhighway, with yields consistently over that industry golden line of 85%.
And get this is the kind of precision we're talking about. TSMC can control the thickness of these sheets with a margin of error of just 0.11 nanometers. That is smaller than a single strand of human DNA. It's not just great engineering. The source we're drawing from calls it a miracle of physics.
And as if that wasn't enough, TSMC solved another huge material science puzzle. As chips get smaller, the copper wiring inside them creates a traffic jam. So TSMC figured out how to replace it with molybdenum, a metal that's notoriously difficult to work with, and that boosted internal signal speeds by a full 20%. Samsung? They tried for 3 years and gave up.
Okay, but if the nanosheets and the new wiring are TSMC's conventional weapons, the source argues that they also have 2 nuclear weapons, architectural breakthroughs so huge that they've basically changed the entire game. The first one is called backside power delivery, and the analogy here is just perfect. Think of a normal chip like a messy, crowded city where all the power lines and the data lines are tangled together on the surface. It causes traffic jams, interference, the whole mess. What TSMC did is like burying the entire power grid underground, leaving the surface totally free for high-speed data.
So what does that actually do? Well, it allows TSMC to pack in 25% more transistors and cut the voltage drop by 40%. It means way more powerful, way more efficient chips. Now, Intel has a similar idea on paper, but they can't actually make them without the chips warping from the heat. TSMC perfected this years ago.
TSMC's second nuclear weapon is advanced 3D packaging. You see, as it gets harder and harder to just shrink transistors, the new frontier is to go vertical, to stack chips on top of each other, like building a skyscraper, to create one massive, super powerful system. This is where the whole industry is headed.
And right here, the gap is just mind-blowing. Intel's technology, Foveros, it taps out at just 2 layers before it starts to have critical overheating problems. Meanwhile, TSMC is already in mass production with stable, perfectly cooled 12-layer stacks. It's not even a competition at this point.
Okay, let's zoom out for a second. Because these incredible technological wins aren't just happening in a vacuum. TSMC has brilliantly turned all of this into an economic fortress.
An unbeatable business moat that their competitors simply cannot cross.
They've basically created the ultimate one-stop shop. Customers get their manufacturing and their cutting-edge 3D packaging all from one place, which creates this really sticky ecosystem that's almost impossible to leave. And then they did something absolutely savage. They took their older 3nm tech, relabeled it as a mature process, and just dropped the price, completely crushing the business case for Samsung and Intel, who are still struggling to make their own 3nm chips profitable.
And the result of all this? The customer lock-in is now absolute. I mean, just listen to NVIDIA's CEO, Jensen Huang. He put it very simply. Without TSMC's 2nm process, their next generation of world-changing AI chips, Blackwell, they just wouldn't exist. The biggest players in tech are completely and totally dependent.
So here it is, the final scorecard for 2026. You've got TSMC hitting over 85% yield, setting the 100% baseline for density, and stacking 12 layers high. You have Samsung stuck under 60% yield with the chip that's actually less dense than TSMC's older 3nm node. And then there's Intel, whose 18A process is dismissed by the source as the biggest PowerPoint scam in semiconductor history, delivering only 70% of TSMC's density.
So, with the battle of 2026 so decisively won, what does the next decade even look like? Well, the scary part is TSMC isn't slowing down to let anyone catch up. They're hitting the accelerator.
This isn't a race anymore. While their rivals are still trying to figure out 2nm, TSMC is already well on its way to 1.4nm with a whole new transistor structure, and they've got their sights set on 1nm right after that. They are creating a technology gap that might be impossible for anyone to close for an entire generation.
Which leaves us all with one final, really crucial question. The picture our source material paints is one of total and complete victory. A world with the power to build a future of AI, of computing, of basically all human progress, is held in the hands of one single company. So what happens next? What does it mean for the rest of us when the blueprint for tomorrow is no longer up for grabs?